All right, good morning, everybody. Batten down the hatches. Here comes another one. Welcome to the Test 6 review. So let's get right on it. Check it out. Coming at you from lesson 28. Don't be afraid to turn back in your book. The first question is 4 decades is how many years? Well, the first thing you better be fully aware of is how many years is a decade? Maybe you know, maybe you don't, but I guarantee you, if you use your book, you can find out that it is 10 years. So you got to think 4 groups of 10 is how many years? Well, that gets a little bit easier then. 4 groups of 10 is 40 years, right? Let's keep checking it out. Here's one. Remember, you got to go and dangle the 0. Right now, that is the only way of multiplying a 2-digit number that technically I've taught you. Maybe you had a little bit of experience in 4th grade, maybe you didn't. And I still see some people trying to dangle the 0 up on top. No, if you're dangling the 0, you got to make sure the digit with the 0 ends up on the bottom. And when you go and dangle the 0, you're not even really worried about that 0. Don't even think of it as 45 times 30. Just worry about 45 times 3. So you start off 3 times 5. Hey, that's 15. I write down my 5. I'm going to carry my 1. 3 times 4 is 12, plus 1 more. That gives us 13. So I'm sitting at 135. Now I bring down my 0 that I dangled, and I end up with 1,350. Check this one out. Coming at you from lesson 13. Jeremy bought 2 sandwiches for $1.35 each. That is the big catchword right there that a lot of us may or may not trip on. And a drink for 90 cents. How much did he spend in all? Hopefully you know in all, that means it's an adding problem. But the trickier part about this is, how are you setting up the numbers you're adding? So he bought 2 sandwiches for $1.35 each. He didn't buy 2 sandwiches for $1.35. He paid $1.35 for the first sandwich, and he paid an additional $1.35 for the second sandwich because he spent $1.35 on each of them. And then he bought himself a drink for 90 cents. So you set it all up. We already know that in all means that it's an adding problem, right? 5 plus 5 plus 0, hey, that's got to be 10. Carry your 1. 1 plus 3 plus 3 plus 9, that's 16. I'm going to write down my 6, carry that 1. 1 plus 1 plus 1, that finally gives me $3.60. It's the each that's going to be tricky on this one. Check out this one. Some people freak out. They say, Mr. Hines, they don't tell me how many people are in the line. Does it matter? Let's take a look, see if it does or not. If Leah is 4th in line, how many people are in front of her? Boy, for as much walking in line as we do, think that Leah is 4th in line. There's always going to be just 3 people in front of you if you're 4th in line, right? If they wanted to know how many people were behind her, that's when we'd have to know how many people were in the line. Check out this one. What temperature is shown on the thermometer? And we don't have all these lines marked. Remember this. We want to take the difference between two consecutive numbers. 10 minus 0, that's 10. And we want to go ahead and divide it by how many unit segments there were. Remember that trick? We're counting the spaces, not the lines themselves. So I'm at 3 right now. There's a 4th unit segment. And it looks like there's 5 unit segments between those 10 digits. So 10 divided by 5, each line is worth 2. So that's good to know. So now let's see, my thermometer line is right here. And I know that each one is 2. This is below 0, so here's negative 2. This has to be negative 4, right? That would be negative 6, negative 8, negative 10. Subtract two consecutive numbers, divide it by however many unit segments there are, and that will tell you what each line is worth. Check out this one. Think of an odd number. And my advice when they tell you to do that, use something small. So I'm going to use 3. Multiply it by 2. And the biggest, trickiest part about this is kids sometimes quit reading there. And they'll say 6, on to the next one. And they forgot an entire sentence. Is the product odd or even? That's how I have to go and check it. So you got a product of 6, so you better make sure to say that, hey, that particular product, I believe that is an even number, Mr. Hines. List the factors of 32. Start by thinking, what times what equals 32? And you're going to want to remember your divisibility rules because a multiplication chart just doesn't cut it sometimes. And then you got to go and list all your factors in order from the least to the greatest. Always start with your easy one. 1 times 32. Every single number out there at least has 2 factors, 1 times itself. Now my divisibility rules. I have a divisibility rule for 2. If it's even, I guarantee that there is some number that will multiply by it, right? But you're not going to find it on your multiplication chart. 2 times what equals 32? Well, you could go the other way. 32 divided by 2. Maybe you know it, maybe you need paper, but that answer is 16. Then I go and I look at 3. Nope, 3 is not going to work. 4 is going to work though. 4 times 8 is 32, and so on and so on. Once you have them all listed, which now I believe we do, now you put them in order from least to greatest. I have 1, I have 2, I have 4, I have 8, I have 16, and I have 32. And I have not used up enough time right now, so I'm just going to keep talking because I have to get all these numbers listed down here. Whew, now I'm ready. It's a good thing my pen works a whole lot better. Check out this guy coming at us from lesson 21. The old number of groups times the number in each group gives you the total. And I already know there's some kids scanning around here going, there's no numbers, Mr. Hines. How can I do this problem? By reading. That's what story problems are about, right? So let's read it. Amana, Vera, Debbie, and Steve equally shared a dozen pencils. How many pencils did each person get? So let's talk about where I'm going to put my variable right now. How many pencils did each person get? That sounds to me like they're looking for the number in each group. Maybe I'll use a P. I have 4 people equally sharing a dozen pencils. Dozen sounds like the total. Now, my number of groups sounds kind of funky, but the number of groups is actually the number of people I have here. I have how many people? 4 people would each get how many pencils if you had a total of 12, right? Once you have it set up, it is pretty easy. Let's go ahead and just isolate this variable, kick it over to the other side, go and rewrite. We have P equals 12, and instead of times 4, what do I want to do? I hope you know by now we are going to divide by 4. Let's go ahead, combine our terms. 12 divided by 4. When I'm ready, I'll just drop it down, but I read left to right. So I'm going to go P first, and I'm going to go equal sign next, and 12 divided by 4, that's 3. Take a look here. It is morning. What time is it shown on the clock? And you got to make sure, because it's telling you it is morning, make sure you label it AM or PM. So, is it 7 o'clock yet? Looks to me like it will be. But if it's going to be 7 o'clock in 20 minutes, is it 7 o'clock yet? No, it is not. It is still the hour of 6. So it's 6 what? 5, 10, 15, 20, 25, 30, 35, 40. And lastly, because they said it is morning, it is 6:40 a.m., right? That one's not too tough. Check out this one. I'm pretty sure I had people today when I was correcting, they did not know what a product was. Feel free to look it up in the back of your book. It will tell you it is the answer when you multiply. So I have 19, and they want to know the product when you multiply it with 8. So set it up one on top of another. Get ready to multiply. 8 times 9, hey, that's 72. 8 times 1 is 8, plus 7 more, that gives us 15, for a grand total of 152. Remember this, do the work in parentheses first. I have 7 plus 6, so we got to think of that as 13. Now go ahead and multiply 6 times 13. Can you do this one in your head? Maybe you can, maybe you can. I'm getting kind of sleepy though. I want to go to bed. I assure you that the product of 6 and 13 is going to be 78. Check out these guys. A quick word. Let's take a look at the dividend right now, right? I still recommend underlining the number you're going to divide into. If I'm going to start at the 9, I'm going to need one number up here, I'm going to need another number here, and I'm going to need another number here. If you end up with a quotient that is not 3 digits long, you automatically should know you did something wrong. And the other heads up, since it's a money problem, there's never any remainder in a dividing money problem in this book. So let's start off. 8 times what is going to get me close to 9? Yeah, that's got to give me 8. I'm going to go ahead and multiply that guy back. 9 minus 8 is 1. I'm going to bring down my next number, and I'm going to park it right next to the subtraction answer. I am back at step 1 now, second time through. 8 times what gets me close to 16? My second digit goes right above the 6. Multiply it back. 2 times 8 is 16. Hey, that's got to subtract for a 0. But I am not done yet. I have one more number to bring down because I do not have anything sitting on top of that 8 yet. 8 times what is 8? My answer there has to be 1. Multiplies back for 8, and it's going to subtract evenly to 0. Last step, dollar sign and a decimal point in the problem. There's got to be a dollar sign and a decimal point in the answer. Check out this guy. Hopefully you know this is saying 300 divided by 4, right? So don't try to set them up on a fraction bar like that. Put them into a divide box, and we're going to take a look at the same thing. I still recommend starting to underline. Is 4 going to divide into 3? No, it is not this time. You got to start at 30, right? So that means I'm going to have a quotient number above that 0 and a quotient number above that 0. Are we ready to divide? 4 times what gets me close to 30? 30 divided by 4. Hopefully you know that's got to be 7. Multiplies back for 28. And it's going to subtract for 2. Bring down the next number. That is a 0. And I'm at the second time through for dividing. 20 divided by 4. 4 times what gets me close to 20? That's got to be 5. Multiply that back. 5 times 4 is 20. And that's going to subtract for 0. So you don't have a remainder yet. Check out this one. We are asked to compare. And I want to remind you that to be considered 1/2, you got to think about the numerator, the number on top, times 2, and see if it equals the denominator. Because 1 times 2, hey, that's 2, right? That's the whole concept behind a half. But if I went 5 times 2, that's only going to give me 10, right? So would 5/12 be more than a half or less than a half? Is 10 more or less than this denominator? This is less, right? So you end up with 1/2 is greater than 5/12 because 5/12 is less than a half. All right, getting pretty close to the end. Check out our next one here. It is asking you, what is the largest 3-digit odd number that uses the digits 7, 6, and 8? So just one quick little review. Remember, it's always the last digit of a number that tells whether it is odd or even. And they're telling us right now that they want us to build an odd number. So out of the choice of these 3 guys, which one is our odd number? That's got to be 7. And it gives you some other hints too, because it asks us to make the largest. So I've already used 7 to determine that it's odd. What am I going to put over here to make it largest? 6 or 8? I think I want to use the 8 up front if they want us to make the largest. So I've used the 8. I've used the 7. Heck, the only one left is the 6. So it would be 867. And that is the end. You definitely want to go slow, careful, and when you double check your test, don't just read over your answers, read the problem, then the answer. So as soon as you're done with this video, you may begin the test, and then after that, either Math After Test 4 or the new Math After Test 5. Good luck.